Hey guys, how are you? Welcome back to the channel. Today is day 24 of upskilling myself, and today I solved 3 DSA problems and I had some internship work to do. So yeah, let's move on to the DSA problems that I solved. So the first problem of the day was reorganized string. So we have been given a string, let's say A, B, and C, let's say, and we have to organize this string in such a way that any two adjacent letters should not be equal to each other, right? So we can organize this like A, B, A, C, A. So you see, a string is possible where two adjacent letters are not equal to each other. So in this case, we have to return the particular string. And for this case, when it's not possible, like A, B, here it's not possible to organize and create such a string. So we return an empty string. Okay. So to solve it, we have to store the character and the frequency of every letter into the hash map. Then we convert the hash map to the vector just for the purpose of sorting it and using it for utilizing the letters on the basis of its frequency in descending order. Right. Then we check if the solution is possible or not, and then we define a string with spaces and start at index 0. So let's say if the length of the string is 5, right? So we define an empty string of length 5, and then we put the characters according to the index. Okay, so first of all, we consider the index as even and fill elements on the even indices. So let's say in this case over here, A is occurred the most number of times, right? So the frequency of A is the maximum. So we will input A on the even places. So A will be over here, and over here, right? Then the remaining letters will be put on the odd places. So B and C. We are doing the same thing over here. And then we have to traverse the vector and add characters in string till the frequency is there. And if the even index is full, then we have to switch the index to odd. You can see over here, if the index is greater than or equals to n, then we switch the index to the odd index. Okay, and then we return the result. So the second problem was longest substring without repeating characters. So we have been given a string and we have to give the substring where the characters are not repeating. So in this case, if you can see A, B, C, its length is 3, but then A is repeated, so we can't consider it. Then if we consider from C, A, B, over here C is again repeated, so we also can't consider more than 3. Okay, so to solve it, whenever we see a substring problem where we have to find the length or the longest substring, we can use sliding window, right? And in this case, when the substring length is not fixed, we will use dynamic sliding window. Okay, so we create a hash map to store the frequency, then we create a left and right pointer and a max length to store the maximum length, and then we add the right character into the hash map while traversing. Okay, so when we traverse the string, let's say A, B, C, A, B, C, B, B. Okay, so first of all, left is equals to right, and then when we traverse until and unless this character, the character that we are on, is not present in the hash map, we increment our right. Okay, so right will be incremented, right will be incremented, as well as the length will be incremented, and length will be compared with the max length, and we will add it into the max length, right? And the right will be incremented after every iteration. When we see an element which is already there in the hash map, as this was there in the hash map, so in this case we will cancel this element from the window and increment our left pointer. Okay, and then we return the max length. The third problem was longest repeating character replacement. So let's say we have been given a string AB. So the k is 2, right? K is 2. So we can replace any two characters. So in this case, if we replace the b's with a, the length will be 4, right? So we have to output 4. In this case, k is equals to 1. So if we replace this b over here with a, the length will be 4. So we output 4 over here. So to solve it, we define a vector to store the frequency. Then we traverse the string and increment the count of the index to character. Then we get the maximum frequency, and if the window size is more than k, then we shrink it, and we have to update the max length after every loop, right? So we get the size, create a vector of frequency, which is initialized with 26 size, so to represent 26 letters, and then we define a pointer which is left is equals to 0, then max frequency and max length. Okay, then we traverse to the array, increment the frequency of right, and then we get the max frequency, which is the maximum of the max frequency and the current frequency of the letter. And then if the length minus maximum frequency is greater than k, then we remove the leftmost element and increment the left, and also we reduce the frequency, and then we get the max length using the maximum of max length and the current length, and then finally we return the max length. Then for the development part, I did some internship work and revision of all the DSA problems that I solved till now. So the internship work is done for now, right? The migration part is done. So from tomorrow, I'll start working on other side project. So thank you guys for watching and see you on day 25.